Welcome to your third lesson on ions. So far, you've learned how to look at any combination of metal and nonmetal and predict the ions that will be formed when those two atoms or elements come together to make an ionic compound. Today what you're going to learn is how to look at the periodic table and predict what ions an element will form without necessarily thinking about it in a particular molecule. So you may or may not have already noticed that you can actually predict what ion an element will form based on its position on the periodic table. So for example, let's imagine just the elements that are in the very first group. Okay? So this group of elements starts with hydrogen. Okay? Underneath of hydrogen we have lithium, and then sodium, and it keeps going. And we know that one thing that all of these elements in this first group have in common is that they have one valence electron. So each of these elements, in order to be stable, needs to lose an electron. So for each of these elements, it doesn't matter what other element it's combining with, it's always going to lose an electron. And we know that if it's losing one electron, that means it's left over with an extra proton. And so it'll have a positive charge. So we know that all of the elements in the first group have a positive charge. Now if we were to look at elements in the second group, let's look at their valence electron structure. In this second group we have elements like beryllium, magnesium, calcium, and there are others. But the one thing that all of these elements have in common is that they all have two valence electrons. So you might be able to see where this is going. If these elements all have two valence electrons, then in order to satisfy the octet rule, they're going to need to lose both of these valence electrons. And so we can predict that it doesn't matter what else calcium, for example, is bonding with, it's always going to need to lose two electrons. So it's always going to have a positive 2 charge. Now we can make similar predictions starting from the right-hand side of the periodic table. If we start all the way on the right, we have elements such as xenon, argon, neon, and all of the other elements in this group share the property of having 8 valence electrons. The exception is helium, but we're not going to talk about that today. So all of these elements have 8 valence electrons. Now, if they have 8 valence electrons, they neither need to gain nor lose electrons. They're already stable. And so these elements here in the very last column, they're called noble gases. And one thing that's special about noble gases is that they can't form ions. And the reason that they won't form ions is that they aren't going to lose electrons because they're happy with 8, and they aren't going to gain electrons because there isn't room for any more in that outer layer. Now let's move in one space from the right, and we have elements such as chlorine, chlorine, bromine. Now each of these are distinct elements, but again they have similar properties, and one of the reasons they have similar properties is that they all have 7 valence electrons. Now if each one of these elements has 7 valence electrons, it's going to be much easier for them to gain 1 and satisfy the octet rule than to lose all 7. So something that all of these elements share in common is that they're going to want to gain an electron in order to satisfy the octet rule. And if they gain an electron, that means they have an extra negative charge, so they're going to have a charge of -1. And I could keep going with the next row in. So the top element on this next row is oxygen. Oxygen has 6 valence electrons. So we can predict that in order to form a stable ion, it's going to need to gain 2 electrons. If it gains 2 electrons, that means it's going to have a charge of -2. So to recap, because you know how to look at the periodic table and predict the number of valence electrons that any one element has, you can also predict what ion it's going to form. What you haven't learned how to do, though, is predict the ions that are going to be formed by transition metals. Transition metals are the metals right here that I'm coloring right now. And they're called transition metals because they are very much metals, but they're sort of in the space that transitions from the very strong metal compounds over to the non-metal compounds on the right-hand side of the periodic table. So these over here are all transition metals. And for where you are in chemistry, you don't need to know how to predict the number of valence electrons or the ions that these transition metals will form. What you do need to know, however, is that a lot of these transition metals can form more than one ion. And given the problem, I will tell you which ions being formed. So a few common examples that I'll give you that are going to be important and come up. One is copper. So copper is a transition metal. And most commonly, copper will either form the ion Cu2 positive or Cu3 positive. Another important example is iron. And much like copper, iron will most often either form a 2 positive ion or a 3 positive ion. So there's one last important concept to talk about today, and that's the distinction between cations and anions, which I think I've mentioned before. So cations are ions with a positive charge. So I'm going to highlight in blue all of the positive ions, or all of the different elements that would form cations. Now, what do all of these atoms have in common other than the fact that they form cations, they form positive ions? Well, they're all metals, with the exception of hydrogen, right? But hydrogen's alone here. It's a loner in this exception. So all of the metals, again, metals are elements on the left-hand side of the staircase, will lose electrons, which means they'll have positive charges when they form ions, and we'll call them cations. So, what's the opposite of that? Well, the opposite is negatively charged ions, which you may remember we call anions. So I'm going to highlight in green all of the anions. So fluorine makes an anion, chlorine makes an anion, bromine, oxygen, and again, all of these elements are to the right of the staircase, which means that they are nonmetals. So a quick recap of what you learned today. You've learned that based on the location of an element on the periodic table, you can predict what ion it's going to form, and that's just based on the number of valence electrons it needs to gain or lose. You've learned that transition metals are more complicated, and they can have more than one ion. So for example, copper can be a 2 positive ion or a 3 positive ion. You've learned that, or you've been reminded that cations are positive ions and anions are negative ions. And I've pointed out to you now that metals are what form cations and nonmetals are what form anions.